So let's see if we can excavate one of these dike walls carefully and see. I'll show you kind of the typical look of one of these internal faces. So that's enough of that. I use one of these makeup brushes. It's embarrassing asking for these at the makeup counter, but I do it. I do it for science. I say I need a women's face makeup brush for science. So the younger set, the Tushy bed, the typical Tushy type dike, the Missoula flood related in age anyway, Missoula flood age dikes, the more numerous and younger set, are easy to carve out. They're unconsolidated. There's if any, cementation is very weak, and generally just unconsolidated sand and silt. But that's a typical wall, internal wall of a clastic dike. Those are clearly flute casts. They clearly have upward pointing noses, and that is some evidence for a downward transport of the fill material. The dike wall itself is almost entirely silt, some fine sand, but it's not clay, it's silt. And it's fairly thin, usually half a millimeter or so. And the idea is that was filter pressed. So sediment filling a fracture, the finer stuff being dragged towards the margin as the water in the fill dispersed or diffused into the drier host sediment adjacent to the fracture. So the finer stuff gets plastered onto the side of the dike as the water migrates out of the dike. So filter pressed. You can see that this dike is goes from here to here, 30 plus centimeters wide. So we're going to excavate this internal wall. So unconsolidated sand, fine sand, medium fine sand. Gingerly carve that back. So those flute casts do show some pretty clear relationship of downward flow. So whatever created these flute casts went like that down.